All right, guys, let's look at the second and last theorem for section 5.2, and it is the third angles theorem. Okay, so this angle tells us that if two angles of one triangle are congruent to two angles of another triangle, then the third angles must be congruent. So let's look at this picture they've provided. So it tells us that angle B and angle E are congruent. And then it also tells us that angle A and angle D are congruent. So without knowing any angle measures whatsoever, just from this theorem, we can conclude that angle C has to be congruent to angle F. Okay, it has to be because these two angles are congruent to these two angles, and so these third angles here are congruent, hence the third angles theorem. All right, so when I look at this diagram here for example number 1, I see a lot of these overlapping triangles, and it can be kind of overwhelming. So I'm just going to draw them out separately. Okay, so this is triangle ACD that I just drew out. What I mean by AD or ACD, I mean the triangle here, ACD. I'm just pulling it out and drawing it separate than everywhere else. Okay, and then I'm also going to draw out BDC. So BDC. Now, clearly these pictures aren't very good. Okay, so A is 45 degrees. Okay, and notice that this has the same marking. So I'm going to mark it and mark it. Okay, now this D here is 30 degrees. And the C has the same markings as that. Okay, well if I look at this, I can solve for angle C because I know that 45, this 45, plus 30 plus angle C equals 180. Okay, so that's 75 plus angle C equals 180. All right, so if I subtract 75 from both sides, I get that angle C is 105 degrees. Okay, well it didn't ask for angle C. It wanted to find the measure of BDC, which is this here. Okay, but wouldn't you agree that this angle has to be the same as this because we know that this angle and this angle are the same, and we know that this angle and this angle are the same, which means that the third angles have to be congruent as well. So angle BDC has to equal 105 degrees as well. All right, let's look at this second example now. Okay, it says use the information to prove that triangle ACD is congruent to triangle CAB. So as of right now, the only way we know how to prove two figures are congruent is to show that all angles or all pairs of angles and then all pairs of sides are congruent. All right, so we know that DC has 2 hash marks and AB has 2 hash marks. So I'm going to say that DC is congruent to AB. We also know that AD has has 1 hash mark, AD, and CB has 1 hash mark, so I can write that. Now notice the third side is AC for both of these triangles. Well, think back to chapter 2, we had the reflexive property where we said something is equal to itself that I told you. I know it seems crazy, but we're going to use it. Now's when we're going to use it. Okay, and I'm going to put by reflexive here just because, I don't know, we need to get used to that anyways. All right, so I've shown that all 3 angles of this triangle are congruent to all 3 angles of this triangle. Now we need to show that we've shown all 3 sides are congruent. We need to show all 3 angles are congruent. So angle DAC has 1 arc, and so does angle ACB. Angle ACD has 2 arc marks. That's congruent to angle CAB. Now the only ones that I haven't mentioned yet are angle D is congruent to angle B. And how do we know those 2 angles are congruent? Well, we know those 2 angles are congruent by the third angles theorem, like we just talked about, and now we know the 2 triangles are congruent.